The waste truck passes through the scale and then dumps the waste via the dumping gate into the waste bunker, where the waste will be stored 3 to 5 days to dewater some of the leachate. With grapple, the waste is transported to the feeding platform. After passing through the feeding hopper and feeding chute, the waste will be pushed onto the grate by the ram feeder, where the drying, combustion, complete combustion, and cooling will happen. The flue gas formed in the process of waste combustion will enter the boiler, where it fully transforms heat with the water and then produce steam with medium temperature and pressure. The steam enters the turbo generator and then generates power. For the generated power, some of it is for in-plant use, and the remaining will be sent to the national power grid. The bottom ash and slag remained after the combustion will be pressed and dewatered and then pushed out by the slag extractor. The owner will be responsible for transporting the bottom ash and slag outside the plant to handle it. The flue gas will be treated downstream with semi-dry activated carbon and baghouse process configuration. The fly ash will be packed by the operator and then transported and handled by the owner. The leachate will be discharged to the wastewater network after being treated. Feed hopper. The function of the feed hopper is to receive and store the waste fed by the grapple while continuously providing waste to the stoker by the weight of the waste. The feeding chute is a ladder-shaped filter. The smooth inner surface makes the waste move easily. A noise insulation layer is set outside to reduce the noise. Feeding chute. The feeding chute is composed of the upper part and lower part. Between the two parts is the metal expansion joint, which is set to absorb the thermal expansion. The waste in the feeding chute is enough for the feeding of the stoker and forms a sealing layer so as to prevent air-in leakage and flue gas leakage. It also separates the furnace with outside. The horizontal section area increases for the top to the bottom. There is an inclined area in the front lower part and an arc area in the rear lower part. The side wall is all the way up to the side frame of the feeder. This design is capable of avoiding bridge top. Refractory material is set at the bottom of the feeding chute to resist abrasion and corrosion and thermal shock. Feeder. The feeding system is located at the bottom of the feeding chute. It pushes the waste into the combustion chamber and feed the waste onto the stoker grate. It is capable of continuously providing waste to the stoker and adjustments to the waste supply according to the requirement. The adverse push grate forms a 25-degree inclined angle with the horizon. The forward push grate is 10-degree inclined angle with the horizon. It is composed of fixed and flexible grate bars. The grate is driven by the hydraulic system and controlled by the DSC. Stable and reliable, the movement period may be adjusted by the combustion condition. Every section of the grate is separated by special-shaped abrasion-resistant and thermal-resistant cast iron. Both the grate bars and separating cast irons are made of chromium and nickel. The primary air is blown into the furnace through the orifice set at the top head of the grate bar. The pressure is comparatively low but is capable of preventing plug-up while ensuring even distribution of the PA on the waste layer. Both the two sides and upper surface of the grate bars have gone through delicate fabrication, so it is able to effectively prevent abrasion. A reasonable expansion space is remained between the fixed grate bars and sidewalls. Therefore, abrasion will be prevented between the sidewall and the grate when it is moving. Clinker wear is set at the bottom of the grate to adjust the depth of the waste layer. Based on the actual operation experience in China, it is proposed to select forward push plus adverse push type stoker grate. This is a new generation mass burn technology with the following advantages. 1. Improvement in heat recovery rate. 2. Reduction of power consumption. 3. Compact facilities. 4. Reduction of maintenance costs. 5. Better environmental pollutants control. 6. High generating efficiency. 7. High efficient dry type exhaust gas treatment. The supplier of the stoker is Sino Steel Equipment Company Limited, who is engaged in the treatment of MSW and has accumulated experience in investment, construction, and operation of several WTE projects in China. The forward and adverse push stoker technology provider is Chongqing University of Science and Technology, CQUST. Mature and reliable, this next-generation mass burn technology embodies world-class level and is very suitable for the treatment and reutilization of Chinese and Malaysian MSW with high moisture content but low heating value, enabling self-sustaining combustion requiring minimal auxiliary fuel. Hence, we are indeed pleased to conclude that the proposed mass burn technology of Sino Steel is suitable for applications in Malaysia because the technology has been technically and commercially proven in China.